Alright, so this video is going to be on the PT Graph CASTLE Learning assignments. I'm not going to be going over the PT Graph worksheet that I gave out, uh, the random one. I'm just going to go over the two that are on CASTLE Learning. So the first question is, what is the magnitude of the object's total displacement after 8 seconds? So again, you know your displacement, and we'll call it DISP, and it's your final position minus initial, okay? And so your initial position is 0. Initial, 0. And your final is going to be, well, at 8 seconds, you see that your point is also at 0. And then you have displacement is equal to 0 minus 0 is equal to 0. And so your total displacement after 8 seconds is 0. Well, if they're asking you to calculate distance, that would be a different matter. Because from 0 to 2 seconds, you're traveling 8 meters. Okay, travel 8 meters. From 2 to 4 seconds, well, you're not traveling anywhere. You're staying at the same place. You're staying at the 8-meter position. And so then from 4 to 8 seconds, you're traveling 8 meters in the opposite direction. So your total distance would then be 16 meters. And if I were to draw it out, let's say east is the positive direction. So in the first 2 seconds, I travel 8 meters. And now I'm at 8 and 0. It's 8 meters. And then I go from, well, for the next for 2 seconds, I don't go anywhere. And then for the final 4 seconds, I travel back to 0. And that's basically what happened there. Alright? So if it was asking you displacement, well, your displacement would be 0. It was asking you for your distance would be 16 meters. All right, let's move on to let's move on to let's move on to number 2. What is the average speed of the object during the first 4 seconds? And again, it wants the first 4 seconds, and you know that your average velocity is going to be equal to d over t, or rather your average speed. Your Since it's speed and it doesn't really matter here, your speed is going to be v, and that must mean that your d must be distance. And then your t is always going to be time. And so what is the total distance traveled in the first 4 seconds? Well, you went from 0 to 4. You see at that point, at 4 seconds, you're at 8 meters, so you traveled 8 meters. And so you calculate this, and then you get 8 meters per second. So that's your average speed. All right, number 3. Number 3. I can kind of do this on the same kind of sheet. I don't really have to erase anything. So, which graph represents the motion of an object traveling with positive velocity and negative acceleration? So, if you have an upward slope, you have a positive slope, right? This is a positive slope. And we know that on a PT graph, your slope is velocity. We know that. We know that to be true. And d over t. Now, the hard part for you guys is figuring out, well, what gives me a negative acceleration? And this is the hardest part. This is the hardest part I find students having trouble with. And I told you in class, same signs, speeding up, opposite, slowing down. Now, it can't be A or C because we have an acceleration. If we have a constant slope here, this is a constant, it's not changing. It's a straight line, it's not changing. It has a constant slope. And that must mean that its velocity doesn't change. And if the velocity doesn't change, well, my acceleration is zero. Acceleration is zero if constant, well, constant velocity. Feel free, hold on, I'm just gonna actually gonna erase, see if I can erase this. Apparently I cannot erase that. That's unfortunate. What the hell? Alright, just gonna erase, sure. Let's erase all this, all this, all this. In hindsight, I should have erased all this. In hindsight. Alright, let's go back. So we have all this information and just kind of soak it all in. So this is a constant slope. If we know that it's constant slope, my acceleration is zero. So it can't be A or C. So now we're left with the choices. Well, is it either B or D? Well, one of these pictures indicates speeding up and the other indicates slowing down. So one of these is speeding up, the other is slowing down. Now, the key here is figuring out, well, how does it end or start? If it looks like it's about to come to a straight line, well, if it's a straight line on a PT graph, let's say at P, that's like it's like 10 meters over here. And well, if at this point in time, let's say this is 10 seconds and this is 20 seconds, if at 10 seconds I'm at 10 meters and at 20 seconds I'm also at 10 meters, that means I'm at rest here. So if this is accelerating, if this is a velocity, well, as I go around this curve, well, then I'm going to come to rest, which means I'm slowing down. Okay, which means I'm slowing down. And so this means slowing down. And now we just answer a question. Well, this graph is slowing down. And if I have a positive velocity upwards, well, if I'm going up, I have a positive velocity. That must mean that if I'm slowing down, my acceleration is negative. Opposite signs. Opposite signs, you're slowing down. And then B is the answer. But let's figure out this first. Again, if we just connect this line over here, again, if we know that a straight horizontal line on a PT graph is staying still at rest, well then once it starts curving out, we know that it's speeding up. Okay, and so D represents speeding up, and so it's going to have a positive, well, it's going to have a negative velocity and a negative acceleration. Okay. Actually, you didn't even need to go for all that. You just need to know that, well, the slope is going up, so it's positive velocity, and then you get your answer. But that's a more in-depth explanation of everything. Feel free to pause at some points, you know? Number four. So we have this distance time graph, position time graph. What's the total distance traveled by the object during 10-second time interval? Well, here is where we're going to put our knowledge of distance. Distance. I don't know why I thought I could continue that. So from 0 to 4 seconds, from 0 to 4 seconds, you end up at 8 meters. Okay, so you travel a total distance of 8 meters. And so I'm going to write between 0 to 4 seconds, you went traveled a distance of 8 meters. From 4 to 6 seconds, you don't really travel anywhere because you stay at the 8-meter mark, so you don't really travel. So you travel a distance of 0. From 6 to 8 seconds, it doesn't matter if there's a curve there. At 8 seconds, you end at 16 meters. At 6 seconds, you start at 8 meters. So if you go from 8 to 16, well, you just traveled 8 meters. Now, if you go from 8 seconds to 10 seconds, if at 8 seconds you start at 16, and if at 10 seconds you end at 8, well, you traveled 8 meters, you traveled a negative 8 meters. You traveled 8 meters in the opposite direction. But the question only wants the total distance traveled. They only want the total distance traveled. So we're just going to ignore this negative sign. We traveled 8 here, another 8, and then another 8. And so we have 8 plus 8 plus 8 is 24. We're ignoring the negative sign here because distance is a scalar. And then this is something I've been saying all this time. Distance is a scalar. Scalar, scalar, scalar. If it was asking you for displacement, well, then you would take the negative sign into account. I traveled 8 meters. Then I traveled another 8 meters. But then I went back 8 meters, and so I end up 0, 8, 16. So my displacement would be 8 meters east. Alright? This is 24 meters. Alright, good. So now let's move on to the second sheet. The second sheet. So question 1 says a cart travels with a constant. This is extra practice, by the way. This is the extra practice assignment. So a cart travels with a non-constant, non-zero acceleration along a straight line. Which graph best represents the relationship between the distance the cart travels and the time of travel? So the cart has an acceleration. So it, yes, not zero, and that slash inside the question equal sign is not. So it's not equal to 0. So it has an acceleration, and it also has a velocity. So it has acceleration and it has velocity. And so again, in a p t graph, that must mean the line is curving. That must mean the line is curving. Now, here is where it gets difficult. Here's where it gets difficult. We can assume, so it's either going to be A or C. It's going to be either A or C. So B and D are not choices because B and D represent constant velocities. If they're constant, there is no acceleration. Now, I'm hesitant to say that either A or C could be answers because they both represent accelerations. Okay, so on a test, I wouldn't really tell you, I wouldn't really give you this type of question. If I did, I would tell you that there are two possible answers. So again, if it's curved, has an acceleration, alright, and if it's curved, it's still curved, it still has acceleration. It's just that there's a negative acceleration here. Negative acceleration. Why is it negative? Well, it's at this point it wants to come to rest. So the slope is going up. It's positive. It's slowing down. So it looks like it's going to be a negative acceleration. So again, you want opposite signs for slowing down. So this slope looks like it's slowing down, but the slope is kind of going up. So you have a positive velocity, negative acceleration. Here, you can just look like you're accelerating the negative direction again. So you have negative acceleration, negative velocity. But, so either answer could be true. I'm not going to ask you this type of question. And if I do, again, I'll mark 2 both correct. So both of these, if it's a curve, it represents acceleration. That was a bit long-winded. Just know that if it's curved on a PT graph, that has acceleration. That's the only thing you need to remember. Which graph best represents the motion of a block accelerating uniformly down an inclined plane? So an inclined plane is kind of like that, and so you have a ball going this way, right? So you have a ball going that way. It's rolling down a hill, rolling down a plane. So we know it has acceleration. We also know that it has a velocity. Well, then that must mean it's curving. Again, if it falls down here, it's speeding up. So if it has acceleration on the PT graph, I must be curving. The line must be curving. And so the only line that curves is D. Alright, D is the only one that's curving. And does look like it's uh, accelerating, getting faster and faster and faster because you're straying farther and farther from a horizontal line, you're getting steeper. You're getting steeper. Alright, so it is D. Let's erase all. So now number three. Number three. During which interval is the cart moving forward at a constant speed? So from A to B, again, we established that if you're going from A in a PT graph, that if you have a curved line, you have an acceleration. This is an acceleration right here. Accelerating. Doesn't matter what type of accelerating, positive or negative acceleration. You just know that if you have a curved line, you are accelerating. So it can't be A. It can't be A to B. Because the question wants a constant speed. And constant, you can't have an acceleration if you're constant. So you're looking for straight, constant slopes. It can be either this or that. These are straight, constant slopes. Why not a straight horizontal line? Well, this means on a PT graph, this means you're staying still. Let's say this is 10 meters. Here I'm at 10 meters. Here I'm at 10 meters. Here I'm at 10 meters. I'm not moving anywhere. I'm at that position. I'm not moving anywhere at all. And so it's either BC or DE. The question is saying moving forward. Moving forward. That must mean you have a positive velocity. Alright, positive velocity. So if you have a positive velocity, well, then your slope must also be positive. This has a positive slope. You're going up. Positive slope. Negative. Negative. Negative slope. Alright, positive and negative slope. And so that answers question 3 is BC. It's all. Displacement time graph below represents the motion of a cart along a straight line, during which interval was the cart accelerating. Well, I drew it before. Again. If you know that you're accelerating, well, you have a curved line. You have a curved line. And so which ones are curved? Well, the only curved line is A, B, A, B. And again, the same thing goes for 5. It asks you, well, during which interval is the speed of the object changing? So again, changing speed. If you have a changing speed, you have an acceleration. Changing speed, acceleration. Changing speed, acceleration. And so if you also have acceleration, well, you know your line is curving. It's curving. It's curving. Any type of curved line works. You know you have an acceleration. It's definitely not a straight line. This is a constant slope. Constant slope. Constant slope. Not accelerating. So it's DE. So the answer for 5 is D. 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 Alright, that concludes the PT graph video.